In this video, we're going to take a look at motion inheritance. It's a dynamics operator. It's going to be useful for having a node kind of affect particles and control them. In some ways, it's similar to the follow and position follow, but we'll take a look at some other things it can do. First off, we'll go ahead and create a couple of rules out here. And in this first rule, we're going to call up a black box. We've created this. It's in our M3D generators. You might need to update some of these black boxes. We'll post them on our website, which is Machine3D. Anyway, you come into this matter waves born, and it's just a simple born particles, gives them shape and size. We'll go ahead and pick the object we want to born on, which is this magenta plane. We're going to use a pistol shot, and we'll set their speed to be 0. And everything else is all set up, randomized emission on the UV. And let's actually see what happens. We're going to go ahead into the second rule that we've got, and we'll call this MOI for motion inheritance. And we'll add that all group we want to affect. We'll come over to the operators. We're in the dynamics category. There's motion inheritance right there. We'll click that and click out here. You can see it needs a particle to affect, which is that, and also a node. So let's go to the helpers node and make that connection. We've got this node out here, this point helper, which comes out and does some rotation and position animation. And we'll go ahead and pick him. And now you can see those particles follow immediately, 100% with that node. This is very much like the effect that we saw with follow, except motion inheritance also has its own set of parameters we can use. We've got inheritance right now set to 100%. If we start to decrease that, you can see that those particles don't quite get the full effect. Or we could also just set it to 100% and add extra variation. So some will have different than others. And also there's rotation inheritance. Right now it's set to 0%. Let's go ahead and actually decrease that initial variation. But in rotation inheritance means that the particle is going to inherit the rotation matrix from their source node there. So go ahead and set that to 100, and we'll see that all the particles, not only will they kind of follow the position of their object, but they're also going to follow his rotation. Let's go ahead and set that to 0 and see that at 0 we can see that there is no position rotation. If we go ahead and set that back to 100, they're all perfectly aligned at the same way that they were born. So this rotation inheritance is going to have each particle rotate like the source node. We'll go ahead and add some variation in there and see that as he, let's get this set up. So he turns around, we can see that some of these particles are being aligned perfectly. Some of them are kind of lagging a little bit. That's because of that rotation variation. And there's also a direction variation where we can kind of throw them out in different directions. Go ahead and change that back to 0. And then there's a distance type. Distance type is going to allow us to use kind of a buffer around this node. We can, right now it's set to none, and so it's just going to go ahead and immediately affect that. But if we set it to sphere, then this radius comes into play. And what will happen is you can see that as that node passes by, only a few of those particles are affected. And you can see in green, our background colors are not very helpful for this. Let's change that. Colors, viewport, background. Let's go to black. You can kind of, that's not very good either. Let's change it. Okay, this color scheme is a little more obnoxious, but at least now you can see this motion inheritance helper. He's got this green sphere around him now, and if we scale up that radius, we can see that it's going to enlarge that sphere, and those particles start to respond more. What this does is creates, a fall-off area around that node, and in the shape of a sphere, and it's going to allow that effect to kind of blend out to particles based on distance. So same kind of thing as follow, it's going to act as a fall-off value, kind of like that speed value in follow. Anyway, we'll go ahead and expand that out, and you can see this radius also has a gradient here. This is going to control how that value falls off. So if we wanted it to be still pretty strong, we'll create a couple keys out here, and then one, make that black. Another. So what's going to happen here is this value is going to be really strong out till about 60%, and then it's going to fade off really quick. And we can kind of see that happen there. There's another way that we can use this. We could actually set it instead of a sphere type to cylinder, and you can see what happens there. And we'll change that radius as well. And that effect, we're going to go ahead and double right click on those to get rid of them. So now it'll kind of fade through there, and you can see once the particles are outside of that influence cylinder, they no longer are affected by the motion inheritance. If we change that cylinder height, of course, we're going to get very different results. And of course, you can use the different axes to align that cylinder. Let's go ahead and recreate a sample that we see quite often in the Cebas example. Give us a sec to set that up. Okay, we've kind of switched things around a little. We've got the matter waves being born off of this plane here. We've got this other object here. This it's just a box that's spinning around around its x-axis, and we can see now that we can see that the matter waves, the inheritance set to 100% with a no distance type. So those particles are going to immediately begin following the motion from this box. So they're going to spin around, kind of following his motion. But you can see that, let's increase their size. We can see that they do not actually rotate as well. So we'll come back to motion inheritance. We'll add a rotation inheritance 100%. And now they will kind of fully follow him. One of the things that we want to explore is looking at the different distance types. We'll go ahead and enable sphere. And you can see that's a pretty small radius right now, so we'll go ahead and increase that. And now as we scrub, what we'll see is that the particles who enter that sphere are going to become affected. You can see them right there in the middle. And then particles who are outside of that sphere don't get affected at all, so it's just what we expect. But let's go ahead and take a look. We actually want to turn this into a cylindrical. This is kind of that famous torpedo scene that we see quite a bit. So as particles come in there and are inside of that cylinder, they're going to get affected. And let's go ahead and we'll actually select that propeller object, and we're going to increase his speed. And let's actually adjust the radius fall off. We're going to have it be a little bit stronger toward the end. And there we see it. Okay. So motion inheritance is very useful for transferring, motion from a node to a particle. It's got these extra controls you can use, distance type as well as fall off, and extremely useful.